Hey guys, hope everyone's doing well. Today we are going to look at Coulombs Law. So we've talked about these charges with positive charges and negative charges. We know they're carried by protons and electrons. And we know the charge of an electron is this tiny number of coulombs. And that charge is measured in coulombs. We also know that positive charges repel and unlike charges attract. Now we're going to go a step further and say, okay, well, we know there's a force and we know what direction it is, but let's calculate that force. And what do we calculate force in, guys? I hope you said Newton's. So this is Coulomb's law, gives you the formula to find the electric force between any two charges. Um, I hope it looks familiar to you. Doesn't this look a lot like force of gravity between two objects, two planets, or whatever we had? F equals g m1 m2 over r squared, where r was the distance between their centers. And so here again, r is the distance between their centers. Q1 is the charge of the first object. Q2 is the charge of the second object. K here is a constant. It's 9 times 10 to the 9. It's going to be a constant, so it's never going to change. It's the same everywhere, so just kind of hold on to that number. Okay, so Q1 is the charge of object 1 or mass 1. Q2 is the object of, or the charge on the object 2 or mass 2, and then r is the distance between the two charges. And so, just like gravity, if you remember when we doubled the distance between two planets, the force of gravity went down by a factor of 4. We could see that gravity follows the inverse square law. That's what we call the when the bottom is divided by r squared. And so Coulomb's law also follows um, the law, like the law of gravity, is also an inverse square law. That means if I double the distance between the two charges, the force will become 1/4. So that's twice the distance, so double it. This becomes squared, so it becomes 2r squared becomes 4r, so it's 4 times. If I triple the distance between the two objects, the force becomes 1/9 and becomes weaker and weaker really quickly. 4 times the distance that it was before, and it becomes 1/16. And so you can see it's a rapidly going thing as the numbers increase. And the same thing happens if I make the distance between them closer. So if I make it half the distance, the force will not double but quadruple or go 4 times as big. If I make it 1/3 the distance that it was before, so I make it, if it was 3 meters, I make it 1 meter, the force is going to go up by a factor of 9. So the force dramatically increases or decreases with distance. And that's the key thing to take away, and that whatever amount you increase a distance with, the force drops by the square of that value. It's the same thing we looked at with gravity, but again, we see it happen again here, and we need to understand that this too is an inverse square law. Okay, so we could look at some basic problems here. You could plug in the numbers here for Q1, Q2, R. They're given to you, multiplied by K, and you would get your force in newtons. Here we'll just kind of look at some example problems that we see that if we double the distance, then the force becomes 1/4 of what it originally was. If I took one of these charges and I doubled it, if I made it from 2 coulombs to 4 coulombs, for example, then obviously the force would go up by a factor of 2 if I increase. This is linear with the charge. If I doubled Q2, the force would double. If I doubled Q1, the force would double. If I doubled both of them, the force would quadruple because it'd be double times double, so it's 4 times. And so the charge is pretty simple to see. If I increase and make the charges 3 times as big, the force becomes 3 times as big. And that's kind of simple, it's linear. With the inverse square, it is the opposite happening, and it's happening by the square of the value. This is just to compare the two together. We're going to be looking at finding the gravity force between two objects that have the same mass and the same amount of charge of 3 microcoulombs. So this U with the long thing, if you guys remember right from the first few days of the first 9 weeks in this semester, in this course, we talked about this Greek term micro, which basically means 10 to the negative 6. Continue next.